Hello and welcome. Today is 5th of December 2020 and this is Daily Math video for CBSE Class 10. We are discussing real numbers and today we are going to take a look at this type of exam question that can come up. Can 8 to the power n? So we are given some number raised to the power n, and what is n? N is a positive integer. So can 8 power n ever end with the digit here 0? Now, you may have a different digit here, but we will go over how do we answer questions such as this. So let's get started. Now, these type of questions, if you do see in your Class 10 CBSE final exams, they will typically carry 2 marks. All right, now let's find out how do we solve a question like this. This type of problem is an application of the Fundamental Theorem of Arithmetic. So what is the Fundamental Theorem of Arithmetic? Let's quickly review. Fundamental Theorem of Arithmetic states that all composite numbers can be expressed as product of prime numbers in only one unique way. So what does that mean? It simply means that, let's clear this up. So let's say we have the number 6. This is a composite number. We can express 6 as 2 times 3. Is there any other way to express 6? Well, you can say, of course, we can write 6 as 1 times 6. But then we are trying to break it down into all the factors that we can, because then 6 we can break it into 2 times 3, right? Or in other words, we can write this as 1 times 2 times 3, right? So we know that these are prime numbers, so we can actually express this is the same as 2 times 3, right? Similarly, let's write the number 20. I'm randomly taking these examples. So here 20 we can write it as 2 times 10, and then we can write this 2 times, so we can break down 10 as 2 times 5, and here we have 2 times 2, we can write it as 2 squared times 5. So the point here is these are all examples of composite numbers. And what we see is that each of the composite numbers can be expressed as product of prime numbers. And not only they can be expressed as product of prime numbers, but this is the only way to actually express them. Meaning there is no other way to express the number 6 in terms of prime numbers except 2 times 3. Similarly, 20, the only way to express 20 as product of its prime is 2 to the power 2 times 5. Now, remember, we are not concerned about the order in which we write them. Meaning, we are not concerned whether it is 2 times 3 or 3 times 2. We don't really care too much about the order in which we write. The most important thing is how are we able to express them. Now, let's use this to answer the question at hand. So, let's first logically think through this. So 8n, so what are the possible values of n? Well, n can be a positive integer, right? So n can be number 1, 2, 3. It can be any of these values up to plus infinity, right? So let us just imagine that there is such a value of n that exists that will give us a number that will look something like this. And it ends with the digit 0. Right? Because the question is, can this ever end with a digit 0? So let us say if there is such a value of n that will give us a number like some number here, and then the number 0, the digit 0 comes at the end. If this is the case, then we can actually easily divide this by 5, right? Because we know that whether it is 10, 100, 1000, whenever it ends with 0, we can obviously divide that by 5. So if there is such a number, then that number can be easily divisible by 5. In other words, that means when we have 8 to the power, this number, whatever we write this number as, there should be times 5. This number must be able to be expressed as something, we don't know what this is over here, times 5. Because only then we can get a number like this that ends with 0. So now can this happen? And this is where the Fundamental Theorem of Arithmetic comes in. Because we know that 8 power n we can write this as, let's do it like this, 2 times 2 times 2 power n, and which will simply mean that 2 cube power n, or this will be 2 to the power 3n. The important point here is when we express this number, the only prime factor that we see is 2. We don't see 5. The fundamental theorem of arithmetic tells us that there is only one unique way to express 8 power n, and which is in this form as product of prime. The only prime number here is the number 2. So this prime number 5 can never be a factor, because this number 8 power n will, or it can only be expressed as something like, so if you have 8 power n, it can be expressed as, something like this, or maybe like this, or maybe like this. It can never have any other prime factor. It can never have 5. So the answer is no. There is no value of n that can make 8 power n end with the digit 0.